Okay, now let us consider a few examples. Xn is a to the power n un. Okay, here a is a real valued quantity, not complex valued, real valued. Now, what is the Fourier transform of this? Xe to the power j omega is, if you put this value of xn here, you will get summation n from 0 to infinity a to the power n e to the power minus j omega n.
Yes, sir.
Because un is 0 for n less than 0 and it is 1 for n greater than or equal to 0. Now, if we simplify this, n is 0 to infinity, 0 to infinity a e to the power minus j omega n, isn't it? To the power n. So this is 1 upon 1 minus a e to the power minus j omega. Okay. Is it always true? What is the condition for convergence of this
Mod A less than
mod?
Less than 1.
Mod a less than 1. This is valid only when mod a is less than 1. Okay, so this is the discrete time Fourier transform. So can we say that discrete time Fourier transform of this signal xn, this a to the power n un, that exists only when this condition is satisfied? Then only it is absolutely summable, isn't it? So the Fourier transform exists only when this is mod a is less than 1. Now, if we sketch the spectrum of this signal, what is spectrum of this signal? This is a complex valued function of omega, and we can sketch x of e to the power j omega magnitude. This is called the, if you sketch it as a function of omega, it is called the magnitude spectrum, and the phase angle as a function of omega, that is called the phase spectrum. Can you tell me what is the magnitude spectrum of this? First, tell me the expression. What is the expression for that? Magnitude mod of x e to the power j omega. Is it a complex valued function of omega?
Yes, sir.
Then what is the magnitude of that? What is the magnitude of this?
1 upon root 1 plus a square.
1 upon root 1 plus a square.
Minus 2a cos omega.
Minus 2 cos omega. What is this? Is it 1 minus a cos omega plus j sin omega? A j sin omega?
Yes, sir.
Now, what is the magnitude of this?
1 upon root 1 minus a cos omega square plus a sin
1
omega square.
minus root 1 minus a cos omega whole square plus what?
A square sin square omega.
A square sin square omega. That is the magnitude, isn't it? And what about the phase? What is this?
Minus tan inverse.
It is minus tan inverse
A sin omega upon 1 minus a cos omega.
a sin, just minus what? Tan inverse a sin omega by
1 minus
1
a
minus
cos omega.
1 minus a cos omega. X e to the power j omega. The phase spectrum and magnitude spectrum are 2 pi periodic functions. Okay, 2 pi periodic in omega. Okay, and when we sketch this as a function of omega, we need to sketch, since it is periodic, we know that it is a periodic function in omega. So we need to sketch it only for one period, that is any continuous interval 2 pi. And generally what we do is we sketch it from 0 in this interval minus pi. Okay, because it is periodic, that pattern repeats, we know that. Is it an even function or odd function? Mod x e to the power j omega?
Even.
It is an even function. That means If we want to sketch it from minus pi to pi, we need to sketch it only from 0 to pi. Take the mirror image. You will get these values, minus pi to 0. Is it? Now tell me what is the value at 0? When a is when omega is 0, what is the magnitude? Suppose I am sketching the magnitude spectrum. When
1 minus
1 minus a. And what is the value at pi? 1 minus a or 1 by 1 minus a?
so 1 by 1 minus
1 by 1 minus a. And omega at pi? Is it?
1 by 1 plus.
1 by 1 plus a. And in between these, okay, anyway, we are not bothered about the shape. I'll sketch, at least you can find these two values. Which one is greater, 1 minus a or 1 plus a? 1 by 1 minus a or 1 by 1 plus a?
1 by 1 minus a.
Is it?
So it depends on A if it is negative or positive.
Depends on a. If it is positive, if a is greater than 0, anyway, the condition for existence is mod a is less than 1, but it can be positive or negative. If a is greater than 0, then which one is greater? This one, isn't it? So this is 1 by 1 minus a, and this is, so the shape is, it is something like this. And this value is 1 by 1 plus a. This is for a greater than 0. And if a is less than 0, it is something like this. Then 1 by 1 plus a is greater. Okay. And similarly, you can find the, you can sketch the phase response of the signal. It is, since it is a worked out example in OpenAM, I am not explaining it. We don't have time to explain that. Okay. You can, it is, all the steps are given in OpenAM. Please refer to that book. Okay, let us consider one more example. It is like for a continuous time signal, we discussed a standard result, that is the Fourier transform of a discrete time, Fourier transform of a rectangular pulse. So in the case of a discrete time signal, let us consider a discrete time rectangular pulse. Zero, 1, 2, let's say up to n1, and similarly minus 1, minus 2, and this is minus n1. Consider this is called a discrete time rectangular pulse. It is only it is a constant 1 from minus n1 to n1, and it is 0 outside that interval. This is called a discrete time rectangular pulse. This is the signal xn. Tell me what is xe to the power j omega? It is summation from what is the expression? Xe to the power j omega is summation n from minus infinity to infinity xn e to the power minus j omega n. That is the discrete time Fourier transform. For this particular signal, it is non-zero, it is 0 outside this interval, minus n1 to n1. So the summation is only over that interval, isn't it? So it is from minus n1 to n1. Then in that interval, what is the value of the signal xn? It is 1. So is it this e to the power minus j omega n? Can we simplify this summation? Let me put m is equal to n plus n1. Then we can write this as summation. This is summation over n, summation m from 0 to 2n1 plus 2n1 e to the power minus j omega n is m minus n1, isn't it?
Yes, sir.
Now can we simplify this? We can take this is summation over m, so we can take this n1 term outside. It is e to the power minus not minus, plus j omega n1 into, will you get this? I'm skipping the intermediate step. It is 1 minus e to the power j omega into 2n1 plus 1 divided by 1 minus e to the power minus j omega. Oh, sorry, there is a minus sign here, isn't it? Is it?
Yes, sir.
So we can't apply that no, sir, because mod is equal to 1 no, sir.
But is
So
it
the
an
jo-
infinite?
jo-
Is it an infinite series?
sorry, sir.
For this is finite. N1 is finite, isn't it? Okay. So can we simplify it further? E to the power j omega n1 into, let me write it as, first let me write the denominator as e to the power minus j omega by 2 into e to the power j omega by 2 minus e to the power minus j omega by 2. Similarly, if I am writing writing this numerator also in the similar form, we'll get e to the power minus j omega into 2n1 plus 1 by 2 into 1 minus e to the power, sorry, not 1 minus, that would be e to the power j omega 2n1 plus 1 by 2 minus e to the power minus j omega into 2n1 plus 1 by 2. Can we write like this? Then tell me, what is the simplified form of this?
The three terms cancel out.
Three terms
Outside the
cancel
bracket.
out, and you will get this sine omega into n1 plus 1 by 2 divided by sine omega by 2.
Yes, sir.
You can simplify this. Okay. Can you tell me what is the shape? This is x e to the power j omega, isn't it? What type of function is this? Is it a real valued function or complex valued function of omega?
Real.
It is real valued, isn't it? And again, from that comes from the property of Fourier transform. This is a real and even signal. Its Fourier transform is also real and even. Same as similar to that of continuous time Fourier transform. Okay. Can I sketch this signal? Okay, let us take an example. For a particular value of n1, again, this is given in OpenAM. If n1 is 1, n1 is 2, then this expression is sine 5 by 2 omega divided by sine omega by 2, isn't it? Sorry, it is not, yeah, it is 5 by 2 omega when n1 is 2. Okay. Now, if we want this, if we want to sketch this, when we sketch the spectrum of a discrete time signal, we know that it is periodic, so we sketch from minus pi to pi. Is it an even function or odd function?
Even function.
It is an even function, so we need to sketch only from 0 to pi. Take the mirror image, you will get the negative part. Okay. Now, can you tell me what is the approximate shape of this? What is the value when omega is 0?
So 5.
It is 5. When omega is 0, it is 5. And when omega is pi, some value. Okay, anyway. Is it a positive value or negative value?
Positive.
It is some positive value. and it is less than 5, somewhere like this. Can you tell me how many zero crossings will be there if you start from omega from 0 and vary it to pi? How many zero crossings will be there? If our objective is to sketch this function from 0 to pi. If we move 0 to pi, what about this function sine omega by 2? Will it change its sign? We are sketching from 0 to pi. If we vary 0 to this function omega from 0 to pi, what about this sine omega by 2? Will it be always positive?
Yes,
Yes,
sir.
sir.
It will be always positive. Now what about this function? Sine pi
Will
by
change sign.
how many zero crossings?
2 times.
Sorry? How many zero crossings?
So 2.
2. Okay, I'm leaving it as an exercise. There will be 2 zero crossings. Find those values, and the approximate shape is something like this. There will be 2 zero crossings and this one. Okay. Then since it is an even function, it is something like this. Okay. This is one period of that spectrum. Since it is 2 pi periodic, its shape will be something like this. Then again, okay. It is 2 pi periodic. Okay. So consider a signal, discrete time signal having this spectrum. Okay, so here pi minus pi. If the spectrum of a discrete time signal is like this, okay, and let's say this is W and this is minus W, and remember, this is not this doesn't mean that this value is 0 outside this. This is a 2 pi periodic function, so it is something like this. Okay, again this pattern repeats. Here also this repeats, minus 2 pi. It is 2 pi periodic. Now tell me, what is the inverse Fourier transform of this? The corresponding signal xn. I can write down the expression 1 upon 2 pi integration over 2 pi x e to the power j omega e to the power j omega n d omega. That is the inverse Fourier integral. So this one, if this is the inverse Fourier integral, now tell me what is the expression for this. In this particular case, xn is 1 upon 2 pi integral from minus w. If you consider one period from minus pi to pi, since it is non-zero only in this interval minus w to w, it is e to the power j omega n d omega. Okay, and I am writing down that expression. So this is, if you do this integration, you will get sine w n by pi n. Is it? This is not minus, this is plus. Will you get this? Is it in the sinc form? Can you convert this into standard sinc form? Tell me, what is this signal in terms of standard sinc signal? How is it defined? Sinc function? Sinc t is sine pi t by pi t. Okay. Now, if we convert this into standard sinc form, will you get this? W by pi.
This is discrete signal.
No, that's okay. I'm talking about that we can convert it into as a sampled version of a continuous time signal. So can we at least write this as sinc Wn by pi? Is it
Yes,
that?
sir.
So you are saying that it is a discrete time signal, isn't it? Can we write it as a sampled version of the sinc function? There is a sinc function. So these values are some sampled values, isn't it? Is it?
Yes, sir.
When t is equal to wn by pi, isn't it? It is a sample version of a discrete continuous time sync pulse, sync function. Okay.